Today we're working on lesson 16.2. This lesson will take multiple days. It is a little long. It's on modeling, which is word problems. Modeling exponential growth and decay. Okay, you need to be taking good notes. I'm noticing when you guys just took your quiz, a lot of you were asking for help on stuff that you didn't write down things. So you need to make sure you're writing down what's important. Okay, there's two different equations we're going to use. One is for growth, and one will be for decay. The growth model is y equals a times the quantity, 1 plus r raised to the t power, y equals a times 1 plus r to the t power. The decay model is y equals a parentheses 1 minus r raised to the t power. Y equals a times 1 minus r raised to the t power. Okay, the a value stands for the initial value. The initial value or the initial amount or the beginning value. So for both equations, a is the initial value. The 1 plus r stands for the growth rate. Growth rate. The 1 minus r stands for the decay rate. Decay rate. R stands for the rate as a decimal. The rate, but you have to convert it to a decimal. So a lot of times they're going to give you percentages. They'll say something like, it changes by 50%, so you need to make it the decimal 0.5. Or if it changes by 10%, you need to make the decimal 0.10 or 0.1. So you will just have to know to change change percentages into decimals for the rate. And then T will stand for time. Okay, so there's the equation for the growth rate and decay rate. So growth is when something like adds value over time, like things appreciate, they are worth more money as time goes on. Decay is for those types of things that lose value over time. And then the other vocabulary word is asymptote. The way you spell that is A-S-Y-M-P-T-O-T-E. Asymptote. An asymptote is the value that the graph approaches but doesn't touch. It's the value that the graph approaches but it doesn't touch. So for instance, on the equation like y equals 0.2 times 3 to the x power. 0.2 times 3 to the x power. So when I have this graph, it's going up something like that. It always gets really, really close to this line right here. It never touches. And that line right there is at y equals 0. That is the asymptote. That's what it gets close to, but it never touches. It's never going to touch 0. If you look at the graph, it always gets really close to 0. It never actually touches 0. Okay, we're going to pause there. We'll keep working on this tomorrow, though.